So these are samples from Matthias, sent in by Tim Turner. This is a new Gecam GT13 machine, and obviously at this point you're not going to see very much, but this is simply the in for the material. You set your material size, thickness, up to a complete 5 inches in thickness. Here on the screen, very simple to use PLC with the adjustments for the belts as they wear, up and down, the top one down, the bottom one up, and your conveyor belt speed and your material thickness. And that's all you need. You can have programs for certain materials that you can store, so all you need to do is afterwards call up in your library basically which program you want to run. Okay? So obviously this is not going to be a tutorial for the machine, but I want to show you a few more features on the machine. One of the most important features on these machines are the way we have the belt guidance. The belt guidance in this is a horizontal belt that runs left to right in the front and right to left in the back. You see that we have actually the blocks straight on top of each other, which fans the abrasive already open, which means we will have more abrasive on the part and we'll have more efficiency. The other thing that is very important is that the blocks have zero deflection in here, which means as the material passes through them, they can't tilt like they do in other cross-belt machines. And therefore we get, again, more material onto the edge of the part, and we get better results, and at the same time we get more even wear on the blocks, and we get less wear in the consumable. So it's a lower consumable, it's more radius, it's faster processing speeds, or a combination thereof, depending on how you want to use a machine. The majority of the dirt all gets basically pushed out to the end, and this is your take up for the dust, and which then passes through here, through the opening in the frame, and then out the vent on the top. So, and it requires about 2,500 to 3,000 CFM to efficiently run. I will leave that open for right now, because another thing that is very important on these machines is that you have very good access to clean. So the machine should be cleaner already as it is, because it brings dirt more decidedly to one side. And then at the same time you have full access to everything that you need to have, other than the upper front panel, which is the electrical cabinet. But in the front you can also remove these two panels to have access to the guide rollers. Now here you see again the horizontal belt with the metal plates and with the blocks. You see the pressure rollers which are very densely packed, which means we have optimum part holding, individually sprung, and also segmented, which means the holding power on these rollers is larger than, for example, on a Lismac machine, where the only three top rollers simply pivot on one frame. That means they always move together. If you run more than one part or two parts in a Lismac machine, the third part will be loose. Then you have the guide rollers that help to stabilize as the belt moves along the straight, and you have a total of 3 of them, 1, 2, and 3. And of course here's your main motor that drives your belt. We have the same assembly on the bottom, the main frame that holds it, and the motor basically that adjusts the brush blocks up and down, and then on top of it we have the chain and the height sensing motor that takes the pressure roll frame and adjusts for material thickness. So you see everything is very nicely accessible, you can see, and at the same time, of course, we can open we have the same door as we had on the other side, we have on this side. So at this point basically we can see through the entire machine and reach it from all 4 sides. And here you see then again the assembly on the bottom with a motor for the height setting of the brushes also on the bottom, and the feed motor for the conveyor rolls. So a very cleanly built machine at an excellent price point, $90,000. And what we'll do now is we'll turn it on and run it, leave the back door open, because this way you can see basically how everything moves. So we have set our thickness for this material here, and we have basically determined we want to run at about 4 feet a minute We have adjusted, of course, the right pressure for our sanding blocks. So all we need to do at this point is, the machine gives us green, we start the machine. Before I do that, I just want to show you something. These are the parts, and of course this is an edge rounding machine, so it's not really, it can remove small burrs and dross like this, and that'll be fine. But if you have a bad cut like here, that looks like this, you will not obviously make a slug that wasn't cut correctly, clean that up to where you have a round hole afterwards. I hope these expectancies are clear. So all we're going to do right now is we're going to turn the machine start, and we want to always run the part at an angle. Processing at 4 feet a minute right now. The part is really cold from sitting outside, and when it comes out in the back it should be nice and warm, about 70-80 degrees. You now see the unit running. The part is coming through the center, and then just going through the back belts right now. It's coming out here, and you can already see the radius on the edge, and you can see the blank surface. And you see what happened to the hole that didn't have a good cut. That needs to be cleaning by hand. You also can see that it is very gentle on the surface. We still see the writing, how we marked the part before, with a small grain in the direction of the belt. And now you have a nice radius, both top and bottom, both on the inside and the outside contours. The small contours, of course, you're going to be doing a little bit less than on the outside contours. I would think excellent part. For these parts, we now reduce the speed to 3 feet a minute. This way you can see a difference in processing, in edge rounding, based on the processing speed. I could also do, for example, 5.1 if that's what I want to do. So, speeding up. PVC coated, I'm a little bit leery. It probably will pull off the PVC. It could be that it's going to pull off the PVC here where we have bad adherence. And of course here we have some adhesion problems. That's how the part was delivered to us. Not sure what happened here. Same over here. And you see where the PVC is loose, there could be some issues. But these edges, you will see very clean. First of all, we need to adjust the material.